Hello, my name is Alexander Day, and this is Lab 2, Charge Across a Rod. Now this lab was very similar to the first one. It was basically the same one, where you had the pieces of tape, and you had to find the charge on the tape, assuming that the force of electricity from the bottom tape on the top tape was the same as the force of gravity that was pushing down on the top tape. We're using the same principles. The net force is 0 because the tape is hovering. We're also using the same, we're using the same fundamental equation that the force of electricity on the top tape is equal to the charge at the bottom tape times the electric field at the point of the top tape due to the bottom tape. However, in this lab, the one exception is, instead of having the strip of tape for both of them as just a single point with all the charge there, we're going to basically divide the tape up into sections and then have each of those little sections act as a point charge, similar to the first one. And we're going to find the electric field from the bottom point charges on the top tape. We're going to add them all up and take the sum of that, and that's what we're going to use to find the force of electricity on the top tape by the bottom tape. And using this new formula, new method, I got that the magnitude of the charge at the top tape is 3.13 e to the negative 8th. This is also the magnitude of the charge at the bottom tape. They're both 3.13 e to the negative 8th. Here's some of our models and formulas. At the right, you have a model of the tape of the charge, tape Q, the distance between the tape X, and then the length of the tape. And as I said, we're still using the equation, the force of electricity should equal the E field times the charge. And we're also assuming the same as the first lab, that the force of gravity is equal to the force of electricity since the top tape is hovering. This is actually the new equation we're using. This is the charge for tape on a rod, 1 over 4 pi epsilon naught, times the charge of the top and basic of the bottom tape over x square root of x squared plus L over 2 squared. This is going to give us the electric field from the bottom tape on the top tape at the point of the top tape, using this distance x, basically in the x direction, or the direction that we have. We're now working through the math. We use the equation force is equal to Ex times Q to get our final answer, which was Q equals 1.13 e to the negative 8th. Checking this by plugging it back in, we get the force of gravity is 1.962 e to the negative 3rd. And the force of electricity is 1.95. Now, they're not exactly the same, but this is most likely due to human errors. Some of them might be that the measuring was slightly off because I was using eye contact to basically do this. The fact that the tape isn't a straight length of a rod, or the fact that the tape probably doesn't have its charge spread evenly through it. There was probably some differentiation on the distance between the two tapes at some points. Also, if we wanted to be more accurate about the actual magnitude, instead of dividing it into 10 pieces, which I did, we could have divided it into more. The more pieces we have, the more accurate it is. Now this right here is actually the model that I was talking about. This is my GlowScript model. And right here we see the red balls and the blue balls. The red balls are the top tape and the blue balls are the bottom tape, divided into 10 pieces. The green arrows are the electric field at the top tape. The white arrow is the force of electricity on the top tape, and the yellow arrow is the force of gravity on the top tape. Now going back to the slides, we have our two questions which are basically the same. It's the first one and the second one are basically why are we using a single point charge to represent this, and what would happen if we had more point charges. easily answered. The reason we have 10 point charges that are representing our line is because it's more accurate than the single point charge. Our charge in real life is spread across the line, which is what is actually happening, and if we had more of these point charge, let's say 100 than 10, it would be more accurate and the real answer, and more of a real answer than the single point charge in the middle.